Super. Okay, so I can see that there's people watching. So welcome to this live stream event, and hopefully you'll have loads of questions about the offerings that we give here. I'm going to give a quick talk about. It's going to take about 20 minutes, and I'm going to talk about the MSc and IoT program, and then in about 20 minutes time, Connor will take over and talk about the MEC, the Master of Engineering, Electronic and Computer Engineering, and he'll talk about that. So we'll just and there's a lot of similarity between the programs. So everything that I talk about is more or less related to what Connor will talk about. So don't fully tune out if you're planning to apply for the MENG in Electronic and Computer Engineering, because there will be content here that's relevant to you as well. Where there's a difference, Connor will explain when we get onto his part of the presentation. So that's it. We're just talking about the postgraduate offerings, really. So just generally in relation to the offerings from the School of Electronic Engineering and the Faculty of Engineering and Computing. We have a number of offerings, and we'll go through those. But just DCU in general, just to give you some information, we're ranked in the top 2% of universities worldwide, which is good. There's a lot of universities worldwide. We're 19th in the world, and we're particularly proud of this fact. We're 19th in the world for graduate employment rate, which is effectively, and especially in the technology disciplines, we have almost full employment. Anybody who's seeking employment can achieve employment having successfully achieved one of our degrees, which is an impressive figure. We're one of the world's leading young universities. A young university is a university that's less than 50 years old, so it mightn't seem that young, but we've been around since the 1980s, so we're still one of the world's leading young universities, and we would consider that with that comes flexibility and adaptability that mightn't be consistent with other older universities, if you like. We're ranked in the top 100 universities globally for social economic impact, and we were the Sunday Times University of the Year for 2021. So you can see we're at DCU as a university is widely considered to be a strong university. Within the school, then, we have had taught postgraduate program offerings for quite some time. In fact, since the 1990s, we've been offering flexible on-campus and remote offerings. So that's quite some time. It is the largest and longest running master's programs of their type in the country. So we would consider these master's programs, the one that I'll talk about and the one that Connor talks about, as being collectively the master's programs in the school. And that's because we share modules between different programs, and we have consistent boards, and our students would mingle between the different programs. So we consider it to be our master's programs, and that's whether you exit with a graduate diploma or whether you exit with a master's, you're on our master's program. So they've been running since the 1990s, and we've very clearly become experts in how we actually deliver these programs. And we know that to meet the needs of students who are in full-time education, we know what's needed. We know how to meet the needs for students who are in full-time employment and studying part-time. We know what's required as well. So we have a long history of working with students to get through the master's programs. One of the things that's important about DCU is that we're a research-led institution. So all of the content that's present on the master's programs is typically aligned with the research interest areas of the academics delivering those modules. So as a result, they're up to date and relevant, and they're very much state of the art in terms of the coverage of the materials in the modules. So that's how we keep currency in our programs, is by adapting our modules over time, allowing the research interest of our academics to feed into the module delivery and design. And as part of our research function, we would have a lot of researchers in the in our faculty in the school who are commercially focused in terms of their research delivery. So as a result, we see that we've had collaborations with industry, and we talk to industry about what are the needs that they would look for from students exiting from the programs. And as a result, we know that the skills that we're delivering are very much in demand today. Okay, so as I said, I'm going to talk about this. So I should have introduced myself. I'm Derek Malloy. I'm a professor in the School of Electronic Engineering, and Connor is Dr. Connor McCardle. He's in the School of Electronic Engineering as well. So we're very much colleagues and we work together. So and these are joint offerings effectively. I'm going to talk about we're going to break this into two sections. So I'm going to talk about the MSc in IoT as we know it, which has a formal title, the MSc in Electronic and Computer Technology, and Connor is going to talk about the MENG in electronic and computer technology with electronic and computing with computer engineering with majors. So he'll go through that in detail. This is a full-time and part-time offering, and it is really what we call the MSc in IoT. It's very, very tightly tied to IoT. So if you're interested in IoT, this is a very good option for you. So the Internet of Things, and I'm sure I don't really have to spend much time on this to the audience that's here. If you're watching, you probably have an idea of what the Internet of Things is. But we would see that the Internet of Things is really a new paradigm in terms of electronic. The sort of emerging electronic and computer technology. We see this as sort of billions of devices talking to each other, affecting the day-to-day lives of people and the functioning of industry hugely. So I don't think there's a single industry that's going to escape IoT. Whether it's in smart cities, industry 4.0, whether it's smart energy, wearable technology, smart home and smart and connected health, these are all areas that are going to be impacted by or if not already being impacted by the Internet of Things. So effectively it's sort of the next generation of the internet, the integration of the cyber world and our physical reality, where devices are effectively reaching out to interact with us in the physical world. So that's what the Internet of Things is, and we would see different and I'll talk about why the sort of the USP of our program and why we believe it's a strong offering. Just some history very quickly. We initially designed this program with Intel in 2014. This was when it was very much an emerging idea, concept, and they had a particular need. So we worked with Intel to design the original program in 2014. This was then extended through a competitive tender. DCU won the competitive tender, and we started offering this program as part of a SkillNet program to part-time students. So I'll explain that in 1 second. And then we extended to the full-time market in 2020. So that would be to allow students who are full-time students who want to study on campus, or international students to attend and study this program as well. So the SkillNet offering is is primarily targeted at students or applicants who are in full-time employments in Ireland and who wish to upskill while retaining employment. And as part of the SkillNet initiative, that allows for sort of continued professional development or in work placement training. So SkillNet supports that, and there is some financial support for SkillNet, provides some financial support for people in that position. So to apply for September 2020 entry, and I'll give you the timelines in a minute, but the next intake is September 2020. First, full-time students apply through DC 896 can apply directly through the application process, and we'll give links to that. And students who are part-time, though, will have to go through digitalskillnet.ie to make the application. You make the application to SkillNet, and then you then follow on with an application to DCU if you've been approved through SkillNet. So that's the process. So part-time through SkillNet, full-time direct entry with that entry code. So why is this program unique? Well, first of all, it's real focused skills. We deal with the real practical elements. It's not just a theoretical treatment of the Internet of Things. We actually do have modules where you actually build systems and build end devices and actually build end-to-end full stack IoT solutions. And effectively, because we're coming from a school where we have an integration and a faculty of engineering computing, the Internet of Things is really about the software world meeting the electronics world. So that means we're covering the full stack. We're covering right from the electronic device, the sensing, the edge processing, communications over the network, to the cloud processing and data analytics side as well, so and machine learning side. So it's a full stack IoT program. We cover all the elements. Again, as I said, our research interests feed into these programs, and that's important to the content. And I suppose we've designed this program, and if you were to look at the difference between this program and the MECE program that Connor will talk about, one of the elements that we've tried to structure a little bit more to make it more accessible for students in industry is that the project elements are slightly more structured than the MECE, in that it's a smaller project and there's structured learning towards it. So that can be a difficulty for some people. If you like a project, you want to do a big project, you could look at the MECE program. If the idea of a very large project scares you a bit, well then this electronic computer technology might be better as support for you. It's supported by flexible delivery models, which has been really important through COVID, and who knows what's going to happen next. We're obviously planning for on-campus delivery and training. There's a question there in the chat. As a VLSI, we do as part of the modules on computer architectures and modules on IoT networks and security, there is discussion of VHDL and so on. I don't know if there's a VLSI specifically in this module. MSc in this program. MSc, so the full-time structure of the MSc in IoT, you would typically you have to do 9 modules in total, 9 taught modules, plus the project elements for 15 credits. So to do the 9 modules means you have to take 4 modules in one semester and 5 modules in the second semester. So typically the first semester, and this will be consistent as well when Connor talks to you, will run from September with examinations in December, and then the second semester begins in January, and the semester runs for 12 weeks plus a few weeks for the examinations. So you would do 4 to 5 modules in semester 1, or 4 or 5 modules in semester 2, depending on the options available or your work or your life demands. You would choose one of the semesters to have a slight imbalance, and then you would do the project elements over the summer months. So in total, you are able to complete the masters within a single calendar year. So it's not what you would consider to be a university year where you start in the September and finish at the beginning of the summer. You go right through the summer, and that's how we are able to squeeze in the entire masters into a single calendar year. It's a lot of work though, because to complete this, you must complete 9 taught modules. These are 7.5 credits each, plus the project element, which is 15 credits, which is 19 credits in total. And just for context, each 1 credit roughly equals 25 hours of work, of study. That could be independent study, preparing for exams, attending lectures, doing assignments. All of those kind of practicums, each 1 credit is 25 hours of study. So just you can get a feel for this. This is very much a full-time program. If you want to complete this part-time, you do it over 24 months, so 2 calendar years. And again, the same structure except for divided in half. You do two modules typically in each semester, but you have to, because you have to complete 9, you have to do 1 in one of the, you have to do 3 in one of the 4 semesters. Plus the project elements, you break the project into half over first summer and the second summer. Again, you do the same number of modules, the same number of credits, and again, the credits are worth the same amount. It's just that you're dividing it over 2 years rather than 1 year. You have a maximum of 4 years to complete the program. But you want to try, we want students to get through it within the 2 years. So just in terms of the question there and probably what people have, I'll spend a few minutes on this slide. This is an indication of the type of content. These are the modules that are currently present on the program. And you can see that we have what we call, first of all, there's this green box, and these are what we call level 8 modules. So these would be considered to be late stage undergraduate modules. So you can do up to 30, you can do 30 credits, a maximum of 30 credits in these green modules. And then you must do everything else then must be in this kind of, I don't know what color it is, purple or something. The remaining 60 credits must be over these ones, okay? So you could consider these are more introductory content, and then these are more level 9. They're more research focused, more state-of-the-art focused, and have slightly different learning outcomes. But as part of the introductory ones, we would see that these two modules here, first of all, we would strongly recommend that students complete both of these. The first one is object-oriented programming with embedded systems, because it's really important to the software required for the other modules, and also mathematical techniques and problem solving, which then feeds into subjects like digital signal processing and to say data analytics and machine learning. So the mathematics in this module is specifically designed to support people who maybe haven't done mathematics for some time and would like to refresh their mathematics as it feeds into the other modules. So it's a custom module designed in engineering with very practical examples applied to the modules that follow on. And that's the way we've designed it. As well as this, then you have a choice, and effectively if you can do up to 4 of these. So you can do if you do these 2, you can do 2 of the following 3. Wireless and mobile communications. Clearly, IoT communication is about wireless devices at the edge, maybe talking to each other or talking over a wide area network to the cloud. So wireless and communication technology is useful as it feeds into that. Web application development is about sort of when the data gets to the cloud, how do you present it? How do you build applications that execute on incoming messages? And so you can see web applications important to IoT as well. And then bioelectronics is really around wearable devices. How do you get information from a human? How do you deal with the small signals? How do you process that at the edge? And how do you generate useful information from the data that you get from wearable devices? So you can see that these are very much, to do 2 of these as options is useful depending on your interests in the IoT. And then you must do 5 of these modules, and you'll see that these are very core to the idea of Internet of Things devices. Connected embedded systems is about building devices that sit at the edge. These could be edge devices. And then how do they communicate to how do they communicate to a cloud solution through protocols like MQTT or CoAP, for example. DSP is about sampling data at the edge and being able to process that data appropriately. Data analytics and machine learning, we feel this is really important. We're seeing a trend in IoT for a move from data-centered, calculations on the cloud to get lower latency and faster performance, pushing that data analytics and machine learning technology to the edge devices, which is important. And we're seeing that appearing in the way that people structured their materials as well. So data analytics and machine learning is about how do you generate useful knowledge from the information that you get from your IoT devices. Network stack implementation is about the communication of data from the edge devices to the cloud. Security, obviously vitally important to any communication application. How do you secure these IoT networks? And I think there's a sort of a focus on edge devices within this module now. Blockchain, again, one of those technologies that you can't escape. How do we build immutable records, immutable storage data, and how do we distribute these around an IoT network? So that's all covered in blockchain. And then a really important module, which is kind of on the softer side, is entrepreneurship. And this came from discussions we had with industry where they said, look, it's one thing our engineers and scientists having the knowledge from these modules, but how do we get them into a mindset where they can then apply this knowledge to their industrial environment, or how do people generate their own companies from the ideas that come from their modules and the project elements? So entrepreneurship is very much an important part of this program, and it's essential effectively at this level that engineers have this sort of knowledge as part of their masters. The project elements which I discussed before, this is broken into, it's kind of slightly structured. There's an RD&I, research development innovation training and project planning session, which is 4 weeks in June. And then you go along to, you develop an idea, and then you take this idea, and ideally we would like people who are in part-time employment to take these ideas and bring them into their work, so as to sort of leverage their work environment with their idea that they develop and turn this into a project over the summer. Yeah, there's a question there, Gerard. First come, first served. At the moment, we don't have caps on the modules, so at the moment you're guaranteed your choice if it's running. So, for example, if a module is available in semester 1, it will be available in semester 1. It runs once a year, so you can choose your selection based on the availability of which semester the module is in. But we don't have caps on modules at present. We haven't had the need to implement that. So it's anybody gets their choice at the moment. So to be eligible for this program, you need to have a 2.2 in a level 8 degree in computer or engineering or any cognate discipline. If you don't have this level, for example, let's say you have a level 7 degree and you've been working in industry, and you have maybe some structured training as part of this, then you can apply and you may be accepted onto a qualifier program. The qualifier program is only for part-time students. There's no full-time qualifier offering, and it's supported by SkillNet as well. And the great thing about the qualifier is that if you're successful once you get onto the program and you work hard, you can complete the program in the same time frame as if you were on the main program with no additional work. So it's kind of structured to enable people through and to give sort of support for people who have come without a level 8 entry. But typically, most students that come in would come in with this entry point having a 2.2 or equivalent in a level 8 degree. Okay, my final slide is just to talk about, we are prepared for COVID-19. We don't know what's going to happen next year, in next academic year, but we're prepared one way or the other. There's a question there about foreign degrees. So the international office does an equivalency on foreign degrees, international degrees, and will give an equivalence to us. So when you make an application, if your primary degree is from an international university, the international office does a rating and then tells us if it meets the criteria, and that's what we work on. So it's a NARIC, I think it's called NARIC equivalent. Okay. So just in case, we have the flexibility. So if you go onto this program, what we would say, and this is true, this is true of the MCTY, this MSc program, and the MEC program that Connor will talk about. We are very well structured to support students who are working either fully on campus, or maybe you can come to some lectures, or you're told by your work environment, no, you need to travel and then you need to continue on. We can continue, you can support you through remote lectures when you're abroad. So we try to build in a lot of flexibility, because at this level people need flexibility. So the way we do this typically, and this is typical, there's slight differences depending on the modules, but typically we have on-campus lectures and they're recorded. So we record, and some modules might include Zoom sessions, and this is sort of on a typical sort of non-COVID scenario. All of the lectures then do video screencast recordings, which are made available as recordings, sort of asynchronous, that you can watch in your own time. Everything is developed. There's a launchpad is through our virtual learning environment called Loop. We support all the students through discussion forums, and that's how you would interact with your peers within this virtual learning environment of Loop. We use open source software and hardware so that we don't require that you end up having to be on campus for one specific activity. Where possible, we try to make everything available so that you can complete this at home or in your home environment. And this has worked really well for us through COVID-19, because it's meant that people could continue their studies and weren't really badly affected, other than we went to Zoom lectures instead of on-campus lectures. So we're quite flexible in terms of the mode of delivery, which is, I suppose, is also a USP for this program. And just in terms of examinations, we typically want to run on-campus examinations, but through COVID, we've been running remote examinations, synchronous examinations, online synchronous examinations, where you're given a time frame and you have to complete the examination in that period. So again, it depends on the COVID situation, or whatever other situation can arise, but we have the flexibility to adapt. Okay. If you have any other questions on this that you don't want to put in the chat, my address is just derek.malloy@dc.ie, and we'll make available at the end. So I'm going to stop share and I'm going to hand over to Connor now. You're muted, Connor, there, I think, again. There you go.
Thanks.
Yeah, that's you, yeah.
Great. Thanks very much, Derek. So as Derek mentioned, we also offer an MEng in electronic and computer engineering, as well as the MSc. So I'll just spend about 15, 20 minutes again going through the details of that program and just calling out some of the differences between it and the MSc. Okay, so hopefully you can see those slides, Derek, yeah?
Yeah, all good, Connor, yeah.
Okay, great, thanks. So the MEng in electronic and computer engineering, which we give a short code MECE to, is a very flexible program that offers a very broad range of modules across a number of specialties, and I'll explain the specific specialties and how you can choose different specialties in this program. So similarly to the MSc, we have entry requirements for the MEng, which are broadly similar to the MSc. And if you don't meet those requirements directly, we also have an alternative entry route through the Master's Qualifier Program for this program as well. So the MEng is designed it targets key engineering, technology, and R&D growth areas. And again, as Derek said, what we teach is very much aligned to our research expertise, which needs to be up to date and cutting edge, and also our linkages with industry, and where we see growing demands from industry, both current and future demands in specific skill sets within this broad area of electronic and computer engineering. So in the MEng, we offer a very broad range of modules. There's 30 individual modules which you can select from with some constraints based on which major you take. And across those modules, the MEng spans a range of areas from semiconductor processing, semiconductor technology, high-speed devices, both optical and semiconductor devices, network infrastructures, devices, and protocols, embedded systems relating to IoT, again, all the way to image analysis, machine learning, data analytics. So how we structure this program for students, given that there's such a broad range of choice, is that you can choose one of 6 different major options, which specializes in one of these different areas. So that's one of the flexibilities of this program, and it's a modular program, which allows you to mix and match modules in a certain way, and it also means if you want to take this program part-time, the modular structure enables you to do that, so you can choose different modules each year over a longer time period if you're taking it part-time, with very few restrictions in terms of which modules you take first, and so on. So we also have 2 different entry time points for the program as well, in September, but also in January as well. So that, particularly for part-time students, that's useful to have that flexibility, given work commitments. It may turn out that perhaps September may not be the best time to start, and you can start the program in January. And I'll explain the implications then in terms of how long the program takes to complete, depending on when you start and when whether you're full-time or part-time. So again, as Derek said, we're very flexible in terms of how we deliver modules, both on campus, a blend of on-campus and remote delivery. And as Derek said, we were well prepared to deliver our programs during COVID, really because we have been offering remote access delivery to our master's modules for part-time students in particular, and students in industry for at least 20 years. So this mode of delivery isn't new to us. We have a lot of expertise in doing this, and we're one of the first master's programs, I believe, to offer this kind of option in Ireland. And as I said, there's also a qualifier route for the program. So I'll just say a little bit about the overall structure and then give some details. So overall, the MEng program, regardless of when you start, or whether you're doing it full-time or part-time, requires you to take 4 core modules that relate to a major, plus 4 optional modules, which you select from another 22 modules, 26 modules, plus a 30 credit majors project. So the 6 different majors you can choose from are here. So they range from image processing and analysis, which involves signal processing, data analytics, image processing, specific algorithms like feature extraction, and machine learning and deep learning as it applies to image processing. So quite a bit of machine learning originally developed around image processing, and that's the context for this major. But of course, as with any of the majors, there are transferable skills generally to deep learning and machine learning from this major as well into other application areas. Then a major in future network technology. So this is a brand new major, or it's running for the first time this year. So we saw a need to have a major that targets specifically high-speed radio and optical technologies as they're going to be used, as they're currently being introduced in industry, and as they're going to be used in the future in all areas of networks, from the access, edge, core, and importantly in core data center networks as well. So that's a new major. It has brand new modules on it, targeting that area that we see as a growing area for application of communication technologies. Then we have major in nanotechnology. So this targets electronic and photonic devices, sometimes called photonics now. So that we're seeing an integration of electronics and photonic devices at all levels, from internally within chips and machines, to establish new high-speed computing technologies, all the way out to large-scale or wide area networks where these or photonics is being combined with electronics. So this major spans both modern electronic and photonic devices and integrates those into one major. And this is very much a devices-oriented module, so it covers the manufacturing processes and practices as well, from semiconductors and photonics. Then the major in semiconductor and plasma technology dips maybe even deeper down into the physical and chemical processes involved in semiconductor processing and manufacturing technologies. So plasma and plasma science is central to electronic device manufacturing. So that will also cover solid state electronics, but has 2 specialized plasma modules. So this major has been popular, for example, with students from Intel, because it very much relates to the modern manufacturing technologies that semiconductor manufacturers apply in order to continue the development of smaller and smaller dimensions and higher speeds in semiconductor devices. Then we have a major in advanced data networks. So this major is at a slightly higher level than the future network technologies major. So it focuses on at the protocol level rather than the device level, and spans wireless, sensor networks, core internet protocols and architectures, and also deals with network engineering and design aspects. So that's the application of mathematics to developing a network design that has predictable performance and cost. So optimization is part of that particular major. And then finally, we also offer an Internet of Things major for completeness on the MENG as well, which covers very similar areas to what Derek has already explained to the MSc. Although the main difference between the major in IoT on the MENG, and the MSc in IoT there are some differences in the module choices and the structure, but the main difference is the nature of the project. So I'll say a little bit more about the MENG project a little later on. So then there's a number of entry points, and you can take the program part-time or full-time, and if you don't meet the requirements, you can start in a qualifier and then transfer onto an MENG. So we have 8 different entry codes then, but overall the requirements to finish the program the MENG program is the same. You complete 8 taught 7.5 credit modules plus a master's project, which is another 30 credits for a 90 credit total. So I'll look a little bit at the details, the structures, differences between full-time and part-time. So if you're taking the program full-time starting in September, it would broadly look like this. So you have 8 taught modules to complete over 2 semesters. Typically, students will split those 4 and 4, but depending on module choices, you might wish to take 3 plus 5. Once you cover the 8, that's fine. So as Derek explained, the semesters run September, December, exams in December, and semester 2 is January to April, with exams spanning normally April and May. So on the full-time program, at the same time as taking your 8 modules in the first 2 semesters, you start your project in semester 1, and you start. There's a selection process. You have a choice of projects. You're allocated a project, and you start researching the project in semester 1. You'll be in contact with a dedicated research supervisor for your project supervisor for your project. You discuss with them and start exploring the technology area or the research area your project involves. Then in semester 2, you move that on towards design. And then in the summer, you have 3 months dedicated to project implementation. So the output of the project will be, demonstrating and documenting some very substantial implementation of some development of some technology or some research topic that your project involves. So this is one integrated process covering the full 12 months on the full-time program. So the project is quite immersive. So you'll see here the project is a single 30 credit project. So it's not quite as structured as the MSc project, which has the research training element and then the project implementation element. So this project, although you work in close collaboration with a project supervisor, but the project is more student-driven in terms of progressing the project during the year. So there are points, the project assessment points at the project and feedback points during in semester 2. And at start and end of semester 2, where you get feedback on your progress as well. So if you start the program in semester 2, then it takes a little longer to complete. So you would take 3 or 4 modules starting in January. You wouldn't have any modules or any activity on the program during the summer. Then you come back in September to complete your modules over semester 1 and/or 2. And you would not start your project until September. So the project, regardless of when you start the program, always runs from September to August. So that would take that would take 18 months then in total to complete the program. So in either case, full-time or part-time, you receive your full transcript of results in November. Graduation ceremonies are typically the next spring, although you can request your parchment earlier than that if you wish. Then on the part-time version of the program, you have more time to spread your modules. So typically in the first year, a part-time student would just take 4 taught modules spread over semesters 1 and 2. You don't start your project in the first year, then you come back the next year, you take the remaining modules and the project. Now, for part-time students, there's the flexibility to spread the program over further years. For example, you could defer taking your project until the following year, and you have in fact up to 4 years in total from the point of entry to complete the program, regardless of whether you start in semester 1 or semester 2. So there's also a January entry option for part-time students. Then the qualifier has again a semester 1, semester 2 entry. I've just shown the semester 1 entry here. So on the qualifier, you must pass 4 modules that are selected from the MENG program, from the same set of modules, before you can transfer onto the master's program. So those 4 modules that you complete on the qualifier are carried over onto the master's registration. So then you just complete your 4 remaining modules and your master's project. Typically, qualifier students take the qualifier part-time. So again, you would have up to 4 years total to complete the program from starting on the qualifier. But it's possible to complete the program part-time, starting with the qualifier in a total of 24 months. So then the entry requirements, so direct entry into the MENG, the entry requirement is a H22, which, as Derek mentioned, is a GPA of 2.5, I believe, yeah. In a level 8 primary honours degree in engineering, computer science, applied physics, or a related discipline. So because we have a broad range of majors options, students can tend to come from different backgrounds. For example, if you're interested in taking the plasma technologies major, then applied physics would be very much an applied physics background would very much suit that major. If you're interested in the other more computing and electronic based majors, then we would recommend you investigate the structure of the program. You may well need some background in computing or programming for some of those majors. Then on the qualifier, if you don't have a H22 in a level 8 or an equivalent, but you have a level 7, which is typically a 3-year program, level 8 is typically a 4-year program, then you can apply for the qualifier. If you have a level 7, we like to see some relevant industrial experience as well as the level 7, and we may wish to have a chat with you as well, to have an interview with you, just to check that your background would be suitable for the for the program and transfer onto the masters eventually, so that we know that we can advise you and we know it would suit you. So the application deadlines then, and I believe these are the same for the MSc. So for September, the application deadline is the 1st of July for international students, for non-EU nationals, and it's a little later, the 31st of July for EU students. The January entry, we don't have the application deadline dates yet, but typically they're at the start of December, end of November. So the application portal for all of these programs is through this link. That you'll find that link on the DCU general program information pages as well. Okay. So there are 6 different majors, and each has its own structure. So I won't go through all of them in detail. All of this information is available with full module specifications, giving the details of what each module entails, on the ece.eeng.dcu.ie site. So you can find this information later, or you can come back to me if you want any more detail. So just briefly, looking at the general structure of a major, as I said, each major has 4 specific core modules relating to that major. So for example, for the image processing and the analysis major, these are the 4 core modules. So you have computer vision central to this major, real-time digital signal processing, data analysis, and machine learning. So both of those modules are mathematically based, covering the fundamentals of the maths and the algorithms relating to computer vision. And entrepreneurship for engineers, which Derek already described. This module also appears in the MSc. So this allows students to translate their knowledge to industry, to innovation within a company, and entrepreneurship, starting your own company in an area. So these translational skills we see as very important. It appears as a core module on this major. It's also available as an option if you wished on the other majors as well. And then the master's project, for each major, you will do a master's project in a topic that's specific to the major. So it'll be related specifically to image processing and analysis if you're taking this major. Then you choose any other 4 modules from the remaining modules. So at the moment there's 22 other modules you could choose from. We will recommend complementary modules that cover some of the prerequisites for the core modules. So that will help you, make your module choices. But you're free to choose other modules if you have already, for example, a lot of experience in OOP, programming, for example, or web application development. You may choose a different option there. So you're free to do that and to further kind of specialize your major. So very quickly, I'll just look at the other 5 majors. They all have a similar structure: nanotechnology, more focusing on electronic nanotechnology, electronic devices, photonic devices, the industrial processes around producing those devices, manufacturing. And again, we'll recommend complementary modules that you take with those cores. Semiconductor and plasma technology, so 2 specialized modules which are delivered by the School of Applied Physics on this major, but also coupled with the engineering aspects relating to device manufacturing and the fundamentals of nano electronics technology and science as well. Advanced data networks, protocols, network protocols, and there's an emphasis here on performance analysis. So using mathematics in the design of networks in order to optimize their performance, minimize their cost, minimize their energy consumption is a key metric these days for when we design new networks using new technologies. Future network technologies, so at the lower layers in the network, so focusing on photonic devices, wireless communication technologies, and future network architectures, including, for example, data center networks. And Internet of Things, which focuses on connected embedded systems, the specialized protocols around embedded devices in order to allow sensors, embedded systems to communicate efficiently with the cloud. So the network end as well as the embedded systems end of IoT. And data analysis and machine learning, as Derek mentioned. Of course, once you have the data, you need an efficient methods for extracting useful information out of raw data. So that module also appears as a core on this major. So there are many different pathways and options on the MENG, but if you apply for this program, you do not have to pick your modules when you apply. You pick your modules a couple of weeks before start of term when you register. And in fact, we have a comprehensive induction session for the program, and Derek also has one for the MSc, of course, and we can advise on module choices at that point after you're physically here in campus, and you can talk to us. And to facilitate that, you can actually change your modules in the first week of term. So you initially register for a set of modules, but you can change some of those if you wish after talking to us or talking to the specific module coordinators about the exact content of the module. So we offer that flexibility to make sure that you've chosen the right modules and major for you. So at this address, you'll find full program details and module details for all of the programs we've presented here, including the MSc. I've given a link for fees information, or you can just search DCU fees and you will find this URL for the specifics on fees. So thank you very much for your attention. So again, I've just given our contact details here. Any questions in the MSc, Derek can answer. I can take any questions after this session that occur to you if you have questions about the MENG or the MEQ.
There's a couple of questions there, Connor, in the chat there. I think it's related to the MEC about the projects.
Okay, great. Thanks. Sorry, I wasn't monitoring the chat. So will the projects be carried out individually or be done as a group? So they're individual projects. Each student gets a unique project topic supervised by an academic who's has expertise in that particular area. So often the project titles, the topics you choose from, are cutting edge, often relate to research or work with industry that the academic supervisor is currently conducting through the research lab. So how the projects work, the process, there's a list of project titles with a short description posted. You make a selection of typically 8 projects in order of preference. You have a chance a week or two to talk to the supervisors of the projects to find out more about the projects. And then at the end of that couple of weeks, the allocation is done and we'll allocate the highest preference on your list that we can. So there can be competition for certain projects, but we make sure that there's a good range of choice. So most students get their, get a preference high up on their list. Yeah. Okay, with the grants for collaborative projects with other faculties like medicine, psychology, etc. We don't formally have a mechanism for doing that, although depending on the supervisor and the types of projects, certainly some projects have involved collaboration before. I had, for example, some projects that had at least an informal collaboration with RCSI, the Royal College of Surgeons in Ireland. And I'm sure that we've other colleagues who would have projects that are ongoing with industry or with other universities or with hospitals, indeed, certainly in the image processing and analysis area. But that will depend, that will vary from project to project. So the thing there would be to speak to if you can't tell by the description, if there is a collaboration involved in the project, you can speak to the project supervisors to find out. Yeah, sorry,
Connor,
Derek,
we also do allow students to propose their own projects as
yes.
part of the process. So, if a student proposes a project that meets the learning outcomes and has sort of they're coming from a background or work employment where they are exposed to medicine, for example, they might have a project idea, and then the coordinator for the projects will invite you to then meet with different supervisors to see if it's suitable for a project in the masters. So, through negotiation, typically they are turned into projects that meet the learning outcomes of the project and are suitable. So if someone has a very strong interest, then yes, we do engage very strongly with that too.
Yes, thanks, Derek. So in particular for students who are registered on the program in the summer before they start their project, that gives them an opportunity to propose a project, and we have a process around that. So it may be, particularly for part-time students in industry, that may relate to something that they're doing or that their company is interested in developing. through a project. For full-time students who start in September, it's generally not feasible there isn't really time to have that, to go through that process of project proposals. But certainly, if you're a full-time student who starts in January, then you have the summer to go through that process, for example. So we will, and we do every year have such student proposed projects.
Yeah, I'm just smiling there with the Intel question. I'll talk about that in a second. There's one here, Connor. I'll have a go at it. The MSc
Yeah.
and the MECE graduate. Yeah, that's an interesting one. And really, the focus we have, and clearly there's certain offerings we have, say, that are more engineering focused, like the plasma is much more engineering focused. The IoT is an example of something that's where software's meeting electronics, if you like. So it's partial electronics, partial software, and there's a trend in industry to understand the sort of an MSc in computing as being a qualification for someone who's a programmer, for example, or an MEng is a qualification for someone who's an engineer who has like electrical or electronics background. So the IoT does span that gap between it is electronics and software. So I think that the qualifications have the same meaning, providing that people understand that it's for that domain or for that area. So typically someone with an MSc, you might think that maybe their skills are more software oriented. Someone with an MEng skills are more, hardware or electronics or, physical layer oriented than otherwise. So I don't think that industry sees a difference really in this space between an MSc grad and an MEng grad. And we've never had an issue where someone has come and said, I haven't been able to get a job because I have an MEng versus an MSc. I think the title of the program is much more important than that. Okay, and just I'll take the next question as well. It's from Vishnu. Is what's the difference between the two programs? Effectively, the 9 modules you take on the MSc and the 8 modules in the MEng are the same modules. So there's no difference in the level. You're not treated anyway differently. So I would consider the taught elements are the same. The major difference is the project. We found that students who aren't used to our project structure need more structure around their training for the project. So I would consider that the MSc project is more structured. It's less independent than the MEng project, which requires a sort of you have to come up with your a strong idea, strong contribution, and work with that. Whereas in the MSc, it's much more about working as part of a module to come up with an idea of how to structure a project, how to plan the project. So it's there's more training against it. So if you're someone who likes to kind of go off on your own and develop something and design a project and work through the project, the MEng probably suits you better. If you need more structure about the way that you and you haven't had any formal training about how you structure a project or create a project plan or what's involved, maybe the MSc might be better for you. So I think it comes down to the project and how comfortable you are with that level of, with that part of the programs. Is that okay, Connor? I think it's reasonable.
Yes. Yeah. Thanks for that, Derek.
Yeah,
That's great. So see the next question. Is this a
2 year.
2-year course?
Yeah.
Well, for full-time students, you can complete either program if you start in September in 12 months, in 1 calendar year. Part-time students can take 2 or more years.
You do have, regardless of how you enter, you do have up to 4 years to complete the programs. That's an academic sort of. The reason for the 4-year limit is because of currency. Like there's no, if you did this over 20 years and you did a module in IoT, it wouldn't be relevant when you got your degree in 20 years time. So the 4-year limit is about currency, how current is the content that you're aware of. So there is a 4-year limit regardless if you're full-time or part-time, but typically people try to do the full-time program in 1 year full-time and 2 years part-time.
Yeah. I should just mention too, for international students, they must take the full-time program. The part-time option isn't available to them for visa reasons. You need to be registered on a full-time program for a study visa in Ireland.
Exactly. Yeah.
Yeah.
There's a funny question there. What type of companies outside are hiring students outside of Intel? We had a lovely graphic. I don't know. It wasn't in this presentation of all the companies that employ our students. And Brian, I don't know how familiar you are with Dublin, but it's the Silicon Valley of Europe, if you like, and that's very true. We see our graduates go on to every company, from multinationals like Intel to startups to well-established companies that have an IoT function or another function you mightn't even think are in Ireland, like that are around. So it's a wide range of companies. If you can think of a name,
Yeah.
our students have gone to work with them.
Yeah, I think we have actually listed some companies that our graduates have been employed by. I'll just call out some.
That's useful, Connor.
Yeah, Google, Apple, Intel, Oracle, IBM, Amazon, Accenture, Analog Devices, Maxim, Boston Scientific, just to call out some of the big names.
Given that Analog Devices and Intel are expanding with the announcements over the last few months, the massive expansions, you could very well end up with a job in Intel. I don't know if you don't want to work for Intel or you do want to work for Intel by the way you've asked the question. Is that it? Any other questions? Okay.
No, okay.
I think we're okay. I think we're good. As Connor said, my email address and Connor's email address were on the last slide. It's just derek.malloy@dcre and connor.mccardle@dcre. And maybe I'll just put the spell. I'm going to type the address, my address in just into the chat. Connor, you might your name in there just in case you want to answer. You don't want to answer a question in the public forum. Ask a question in the public forum. How did you do that?
I'm not sure what I did there. I replied to your email, did I? To your message. Okay.
Super. Yeah. Okay. Thanks
Great.
everyone for attending and for your time. And we'll stop the stream. And look, if you have any questions, we look forward to seeing you in DCU. If you make an application to DCU, we'd really look forward to seeing you there. And you'd be working with both of us. We're heavily involved in the running of the programs as well. So. We're always available for a chat if you end up on campus. So yeah, if you have any questions, send them on to our email addresses. And thanks very much for your attention and spending an hour with us today.
Okay, great. Thank you.
Much
Much appreciated.